5.3 Multiplying Polynomials. So multiplying polynomials, in here we're going to review how to use the distributive property. If it is two terms times two terms, a binomial times binomial, how to do foiling methods, and reviewing all these shortcut formulas. So example 1a, it is a monomial times a monomial. When you are multiplying monomials times monomial, we use the properties of exponents from the previous sessions that we talked about before. So this will become negative 15 s to the second power plus 6, because it's the same base, and t to the first power plus 4. So which give us negative 15 s to the 8th power and t to the 5th power. That would be my final answer. Example B is using distributive property. So when we do the distributive property, we multiply to every single term. So this will become 3 4 times 2. That will become negative 3 to the second power. And this is where I'm going to start skipping the step. D to the third power times D to the fifth power. Same base, so we add the exponent, it will become D to the 8th power. Now distributing the next term. So 3 4 times 16 over 9, you can do on a side work like this, or use a calculator, whichever is okay for me. So 4 goes into 4, and then 4 goes into 16 4 times, 3 goes into 3 1 time, and 3 goes into 9 3 times. So this will give me plus 4 over 3 d to the 5th power. And lastly, it will become minus 4 goes into 8 twice, so it will be 2 times 3 is 6d to the 3rd power. That will be my final answer for this. And the next example is basically 2 term times 2 term, a binomial times a binomial. And I cannot use any of these three formulas because they are not identical. So I'm going to use the foiling method. Foiling method is multiplying the first together, which will be 8y squared, and then outer, that will be negative 12yz, and then multiply inner, which is going to be negative 2yz, and then multiplying the last together, which is plus 3z squared. So combining like term, that gives me 8y squared minus 14yz plus 3z squared. That will be my final answer. Moving on to the next example. Again, this is a binomial times binomial, so it's foiling method. So my outer will be 6f squared. The outer will be negative plus 4fs, and the inner will be negative 15 fs, and my last will be negative 10s squared. So this will become 6f squared minus 11fs minus 10s squared. Continue on the next example, and notice that my first and last are identical with opposite operation. So this is difference of two square format. So I can basically say the first square minus last square. So it will be 2 over 3x squared and then 4 over 5. So we are using the formula. So that would be equal to 2 over 3 squared is 4 over 9x to the second power minus 16 over 25. That will be my final answer. So for this one, I can see that it's first and the last square. So according to the formula, that will be first square plus 2 times first times last plus last square. Or you can write it out 3x plus 7y times with 3x plus 7y twice and then do the foiling. But I would recommend you to practice using the formula. Okay, So once again, the formula is first square plus 2 times first time last plus last square. So my first is 3x and 3x 7y and then 7y. So next step will be simplifying it. So it will be 9x squared plus 6 times 7 is 42xy plus 49y squared. So far these are the problems from Math 115, elementary algebra. Now we're going to look at the type of problems from Math 125. So it's the same thing, but you have to be able to recognize in the formula format. So for this one, you can look at it as this will be my first, and this will be my last, and this will be my first, and this will be my last. So you have first plus last and then first minus last format. So this will give us the formula first square minus last square. So my first will be x minus y, my last is c. So using the shortcut formula again right here, it will be first square minus 2 times first time last plus last square minus z square. So this will be x, xy, and y. So my final answer will be x squared minus 2xy plus y squared minus z squared. So you can try the same thing for example H, right? So example H will be, again, you look at this as your first and look at this as your last. So this will become first square minus last square. So 4k minus p and then 2 square. And the first one, you use the shortcut formula first square minus 2 times first time last plus last square minus 4. So it will be 4k times p and then p square. So this will become 16k square minus 8kp plus p square minus 4 will be my final answer. Then we move into polynomial functions, which is learning the notation like in adding subtracting sessions. So when I say two polynomial functions, function f times and function g of x, that means f of x times g of x. So looking at example A, that will be basically talking about f of input x times with g of input x. Substituting back with the formula, my f function is x minus 5 and my g function is x squared minus 2x plus 3. So what we need to do is we need to do the distributive property right here, a binomial times a trinomial. So using the distributive property, so x is going to distribute it into all three terms, which will become x to the third minus 2x squared plus 3x. And the same thing, I'm going to distribute the second term to all of them. So which will become negative 5x to the second power plus 10x minus 15. And finally, we're going to combine like terms to get our final answer, which will be x to the third minus 7x squared plus 13x minus 15. And that will be our final answer. So the key thing is recognizing the notations from here to there. So example B, we evaluate at a specific input value now. So this means f times f of negative 2, right? F functions evaluating at negative 2 times with g functions evaluating at negative 2. So therefore, first we need to evaluate each function and then multiply the function values together. So f of negative 2, that is basically input times input minus 5 when we talk about g of negative 2, that is basically input square minus 2 times input plus 3. So let's look at on the f function. My input is negative 2, so negative 2 minus 5, right? Negative 2 minus 5, that is equal to negative 7. So we know that the value of f of negative 2 is negative 7 times with now evaluating g of negative 2. So my input is negative 2, negative 2. So this gives us, when you compute it, negative 2 squared is 4, and plus 4 plus 3, which is going to be 11. So now I know that function g evaluating at negative 2 is 11. Multiplying negative 7 and 11, that will give me negative 77. That will be my final answer, and this concludes this session.